Hello students, welcome to Vista's Learning. I am Harshitha, your chemistry tutor at Vista's Learning. Vista's Learning is an online education platform where we strive to provide quality education for all. So this is our last session of our fourth chapter, that's Chemical Kinetics. So in this session, we will be discussing all the NCERT question and answers. A few of them we have already discussed as we took up all the topics. But a few of them which is quite important, which can be even asked as an MCQ, I am going to be solving those questions in today's session. And along with those, I will even be talking about a few MCQs, which is very important. Fine. And you can, based on this particular MCQs what I'm showing, you can actually solve a lot more MCQs which is coming from the same particular topic. Fine. So we'll just have a recap of what we studied in the previous class and then we shall go ahead with today's session. So we got to know how exactly the catalyst is going to affect the rate of the reaction, right? We learned about that in our previous class, and how exactly if a catalyst is introduced into the reaction, then the rate of the reaction increases really well. How does it happen? It's because of the activation energy which decreases when catalyst is being added. When the activation energy decreases, what happens to the rate constant? Rate constant increases, which also increases the rate of the reaction. Fine. And we also saw collision theory of chemical reactions. So collision theory of chemical reactions, right? This collision theory, what was it based on? Collision theory was based on collision frequency, as in how many collisions, okay, how many effective collisions were taking place per second per unit volume in the reaction mixture. That is a collision frequency. So if the collision frequency is high, then the rate of the reaction also increases the similar way. Okay, they are directly proportional to each other. We saw how exactly this collision theory is being dependent on the threshold energy as well as our activation energy. Okay, threshold energy, and there's one more thing that we have to see. If the threshold energy of the reacting molecules are really, the kinetic energy, whatever they possess, if it is of good rate, then the collision will be effective in nature. If it is not happening, like if the collision is not taking place properly, then the threshold energy is not that great. If the threshold energy is not up to the extent, then the chemical reaction will not take place faster, in a faster rate. Fine, threshold energy. And the next thing was proper orientation. Clear? These are the two things which are going to be present in the collision theory. As in, if both of these factors are being met, then we can say how exactly the collision frequency plays a role and how exactly the rate of the reaction is being dependent on collision frequency. We also introduced another factor which is called the probability P, or the steric factor. That is for proper orientation. Clear? So we'll start off with today's session with our first problem. Fine. So what is the problem saying? We'll first read the problem, as we know the drill. We'll read the problem, we'll try to get the data, whatever is being given in the problem, and then we'll proceed with our question. So, with our answer. So the decomposition of NH3 on platinum surface is zero order reaction. What are the rates of the production of N2 and H2 if K is equal to 2.5 into 10 to the power of minus 4 mole per liter per second. So what is given over here? Decomposition reaction of NH3. Fine. What is the order of the reaction here? It is zero order. Decomposition of NH3, which is a zero order reaction. So they have given the rate constant already, and they've asked us to find out the rates of production of N2 and H2. Okay. First we shall write the reaction. So our reaction is going to be NH3, right? Decomposition reaction. Okay, so we'll balance it first. How many N molecules are there on the reactant? As in, how many nitrogen are there in the reactant side and how many nitrogen are there in the product side? We know this. There are 2 here, so that's why I'm putting 2 over here in order to balance it. So total there are 6 molecules over here. 6 molecules of what? 6 molecules of hydrogen, for which I'm going to be putting here 3. So 3 to the 6 molecules are there on the product side as well. Now the reaction is being balanced. they have given the rate constant, okay? K is equal to, our rate constant K is 2.5 into 10 to the power of minus 4. They have told this is the zero order reaction. So for a zero order reaction, the rate is nothing but K into concentration of the reactant to the power 0, correct? It's a zero order reaction. So when it is 0, this is going to become equal to 1, correct? So what exactly is the rate of NH3, rate of the reactant? It's going to be equal to K itself. So what is K? 2.5 into 10 to the power of minus 4 mole per liter per second. Okay, it's the same thing here. Here, now they have asked us to find out the rates of production of N2 and H2. Okay, we know our rate can also be written in this particular way, where the rate is going to be equal to dr by dt. If it is in the reactant side, we are going to put negative, and in the product side, we are putting positive sign. So first we will write for all these, right? For NH3, if we are writing, what exactly will be there? Minus d NH3 by dt. And what is going to be for N2 and H2 over here? Positive here. Here also positive. Here. So here NH3 molecules, how many are there? 2. So what will I be writing over here when I'm writing the determinants of it? I will be taking it as 1 divided by 2. Okay. And how many N2 are here? There's only 1. So 1 divided by 1 is going to be 1 itself. And when I'm talking about H2, how many H2 molecules can you find over here in the reaction? There are 3, right? So what will I do? I'm going to divide it by 1 by 3. Now they have asked us to find out the rate of production of N2 and H2. So for N2, we know this is going to be equal to the rate of our reactant as well. Whatever the reactant rate that we found out, 2.5 itself. So the same thing is going to be there for N2. Clear? So the rate of production of N2 is going to be equal to K, which is equal to 2.5 into 10 to the power of minus 4 mole per liter per second. And what is going to be for H2? There is 1 divided by 3. When I'm taking it to the right hand side, it's going to become 3 into K. So here this is also equal to K itself, right? 3 into 2.5. 3 into 2.5 into 10 to the power of minus 4 moles per liter per second, which is going to give us 7. Fine? 7.5 into 10 to the power of minus 4 moles per liter per second. So these are the rates of production of N2 as well as H2. Clear? It's an easy problem, and which is frequently asked in your MCQ type. Okay, so they're just going to give you what exactly will be the rate. They'll give you different rates over here. We just have to find it. Okay, it's quite easy. We know it is a zero order, first order. Based on that, we'll write the order of the reaction. We'll find out the rate, and from which we can find out what exactly are the rates of the particular components that they have asked us for. Now the next question. So a reaction is second order with respect to a reactant. Okay, this reaction is a second order reaction with respect to what? With respect to the reactant. How is the rate of the reaction affected if the concentration of the reactant is doubled? First case. The second case is reduced to half. Okay, so they're asking us what exactly will be the rate of the reaction. How is it being affected when we double the concentration of reaction? That's your first case. And in the second case, we are just going to take half of it, which is reduced to half. So first information that is being given to us, what is it? It is a second order reaction, right? So for second order, we'll write the rate is equal to K concentration of A to the power of 2, right? Which is going to be equal to K A square. Simple as that. This is how the rate of the reaction is going to be for a second order reaction. Now the first case. So what is the first case given here? Concentration of A is being doubled. Okay, the reactant here I'm taking it as A. That's why I'm just telling A. Okay, concentration of the reactant is being doubled. So if the concentration of this is going to be doubled, we can write it as A is equal to 2A. Clear? Now I'm just going to put this into the rate expression and find out the rate. So this rate is going to be K. What is the concentration of A? 2A. Square of it. So it's going to be 4 Ka square. What is Ka square? There's one thing that you have to see. This rate, okay, yeah, this rate I can write it as just R. Whereas this rate I will write it as R1. Okay, so which is going to be R1 is equal to 4R. Is it not? Okay, why am I writing it here as 4R? Ka square is nothing but R. So I'm just going to be substituting here. So this can be asked in your MCQ types. It's commonly asked in your MCQ types. Okay, how will they ask? They'll give you 4 options with respect to what is the case when it is doubled, what is the case when it is reduced to half. You have to just click the, select the correct option, which is giving this as well as what we are going to be solving, the second case as well. Second case, what is happening here? It is being reduced to half. Okay, so what is being reduced to half? The concentration of A has been reduced to half. I can write this as half A. Clear? Concentration of A is being reduced to half, so I'm writing here at half A. So now I'm just going to substitute this in the rate expression. K into half A square, which is going to give us 1/4 Ka square. Okay, this rate I'm going to be taking as R2. Clear? So if it is R2 is going to be equal to 1/4R. Clear, students? So these are the two cases. Okay, these are the two answers they'll be giving. Okay, in one option only there'll be 2 divisions. One will be for your first case and the other one will be for your second case. So you just have to select the correct answer. There'll be different types of answer. You just have to, it's very easy actually. By this, if you know, if it is doubled, it's going to be 4 Ka square. If it is going to be half, it's going to be 1/4 A square, as in 1/4 R. Clear? So we'll move on to our next question. Okay, this is an MCQ type. Which of the following is affected by catalyst? So which of the following given data is being affected by the catalyst? So what did we see? Catalyst is going to be affected by activation energy. That's the first thing that we saw. Then catalyst is going to be dependent on collision frequency. And then the next thing what we saw, that was our catalyst also is going to be affected with the probability, right? P into ZAB, E to the power of minus EA by RT. Okay, AE minus EA by RT. I'll just write that. We saw that as rate, which is equal to, we saw probability, we saw ZAB, right? Then we saw AE to the power of minus EA by RT. So these are the factors on which the rate of the reaction is being affected in that catalyst, right? When we're talking about catalyst. So what did we see with respect to effect of catalyst? I already did a revision in the starting itself. So the catalyst is going to be dependent. Okay, catalyst is not going to be, as in the rate of the reaction, when the catalyst is added, it is not going to alter the Gibbs free energy. That's the first thing. The second thing, what is not going to be altered when the catalyst is being added, that is going to be our equilibrium constant. Okay. This is our equilibrium constant. So we saw when the catalyst is added to the reaction, the activation energy, okay, the activation energy barrier, whatever we see, I mean the hump, whatever we saw, right? This, if I'm taking, okay, I'll just explain with the graph itself. Here it's going to be energy, and here it's going to be reaction coordinate. If this is where the reactant is there, it needs to cross this barrier, as in it needs to get so much energy in order to form the product. This is without the catalyst which is being added. When the catalyst is added, what is exactly happening here? Okay, when the catalyst is being added, okay, here it starts the same way, but the barrier is going to be reduced. Right? The barrier is actually reduced over here. So what exactly does it mean? The activation energy is being reduced. Activation energy is being reduced. So when the catalyst is being added, only the activation energy is changing. Okay. Apart from that, we don't have anything to deal with delta H, delta S and delta G, because as I told you, Gibbs free energy is not being altered. So when delta, I'm writing it here, when delta G is equal to delta H, right? Delta H minus T delta S. This is the Gibbs free energy equation. So none of this is going to be altered. As in when I told the Gibbs free energy is not going to be altered, that actually means that nothing is going to be changed with delta H as well as delta S. So which is the correct option over here? It's A. Okay, option D. Based on this, there's another way where the question can be asked. As we go throughout the session, I'll just tell you about that as well. Okay, I have a problem which is coming ahead. The fourth one. What exactly is the question saying here? Calculate the half-life of the first order reaction from their rate constants given below. So they have given the rate constants here already. We just have to calculate the half-life period of which order reaction? Of first order reaction. So for first order reaction, what exactly will be the half-life formula? T half, which is going to be equal to 0.693 by K, right? Okay, so they have given us the rate constants in 3 cases. We just have to find out T half. Here, what should we remember? We should remember the half-life period for first order. So what exactly will be the half-life period for 0 order, first order, second order? If you know these formulas, we just can substitute whatever data it is being given to us and then calculate the answer. Simple question, the same way it will be asked in the MCQ type, can be asked. Okay, first case. Okay, it's 200 second inverse. Okay, we need to find out the rate constant. They have given us the T half. So what will it be here? We just have to interchange the equation over here. I put K over here and T half over here because I need to find out K. 0.693 by K. Here, sorry, by T half. Here the case is 200 second inverse. Can you all calculate along with me and find this answer, which is going to be 0.693 divided by 200. 0.003465. So if I'm going to move the points, then I'm going to be getting 3.465 into 10 to the power of minus 3 second. Second inverse is going to go up and then we are going to get second. This will be the rate constant for the first case. And for the second case, what will it be? 2 minutes, right? So for 2 minutes, how can I write it? Same case. K is equal to 0.693 by 2. Okay. So what will be the answer? Here it is minute inverse. When I move it up, I'm just going to get minute. 0.693 divided by 2, 0.3465. 0.3465 minute, which is going to be the value of K. The third one, 4 years inverse. K is going to be equal to 0.693 divided by 4. Here it's going to be years inverse. 0.693 divided by 4 is going to give us 0.17325. 0.17325 years. Clear? So these are the 3 rate constants that we had to find out. Simple. Now we'll move to the fifth question. So what exactly, this is an MCQ, the same concept what we learned, okay? Which of the following statements about the catalyst is true? So they've given us a few statements, they're asking us which of the following is true with respect to the effect of catalyst. A catalyst accelerates the rate of the reaction by reducing the activation energy. Okay, it accelerates the rate of the reaction, as in it increases the rate of the reaction by reducing the activation energy. The second option is a catalyst does not participate in the reaction mechanism. Third, a catalyst makes the reaction feasible by making delta G more negative. A catalyst makes the equilibrium constant more favorable by forward reaction. This is the straight cut answer. Option A is correct. Why do we say so? That is because right now we discussed, right? Catalyst is something which when added to the rate of the reaction increases. First thing. So rate increases means activation energy is decreasing. When the activation energy decreases, that's when the rate of the reaction is actually increasing. Okay, a catalyst does not participate in the reaction mechanism. It does participate in the reaction mechanism. An intermediate complex theory, as I spoke, right? There's going to be an intermediate which is going to be formed, which is unstable, and it moves to form a stable product. So that's a wrong statement. A catalyst makes the reaction feasible by making delta G more negative. No, it's not going to alter delta G at all. D, a catalyst makes the equilibrium constant more favorable for forward reaction. It makes both forward reaction as well as the backward reaction at the same rate. The speed is going to be the same. Clear, students? So it's a straight cut with option A. Similar type, see I told you, right? Effect of catalyst is one such topic where a lot of MCQs can occur. With the same concept, it's just that the question is being twisted a little, that's all. We'll go to our sixth question. Half-life of radium is 1580 years, 1580 years. Its average life will be. So they've asked us to find out average life. Okay, they have told us the half-life of radium is so many years. Find the average life. So first thing that we have to see, this is a radioactive element. Okay, this is a radioactive element, radioactive reaction which is happening. So in any radioactive reaction, right? It's going to be first order. Okay, radioactive reaction is going to be first order reaction. So if it is a first order reaction, they have given us the half-life of it. Okay, the T half is going to be 1580 years. Its average life will be. Okay, what exactly is the average life they are asking? So here we know for first order reaction, T half is nothing but 0.693 by K, which is the rate constant. But since we are talking about average life over here, we'll be not basically talking about K, but we'll be talking about radioactive decay. So what exactly is radioactive decay, which is 0.693 represented as lambda. Okay, this is radioactive decay. They have asked us to find the average life. First, we'll find out what exactly is going to be lambda. That's a radioactive decay. 0.693. I'm just interchanging here. Okay, so what exactly T half is given over here? 1580. We just have to divide it. But here, since I'm talking about average life is nothing but 1 by lambda. It's 1 by the decay. Okay, so if I'm just going this, if this is taken as 1 by entire amount, we just have to interchange it, as in the denominator moves to the numerator side and the numerator comes down. Simple. So 1580 by 0.693. That is going to give us the average life. Can you all check with me the answer, which is going to be 1580 divided by 0.693, 2279. Clear? It's going to be 2279. This is going to be the average life. This is going to be the average life of this particular reaction. Okay, half-life of the radium element. So which is the option over here? So 2279, right? Which is the nearest over here? 1832, 2.25, 8.825, 2.275. So here, why is it into 10 to the power of 3 is, it's 2279, right? So I'm just going to move the points this side. Okay, 1, 2, 3, which is going to give us nothing but 2.279 into 10 to the power of 3 years. Clear? So this is your answer. This is your last question for this particular session. Okay, so what exactly is this question being saying? For the decomposition of azoisopropane, the azoisopropane is being decomposed to form hexane and nitrogen at 543 Kelvin. The following data are obtained. So what is the data that's obtained? At particular time, what exactly is the pressure? They have asked us to calculate the rate constant. Clear? So what is the decomposition reaction of azoisopropane? Azoisopropane. It's not equal to, right? It's going to give us what? C6H6, which is benzene plus N2. Here, now the following data is being given. We need to calculate the rate of the reaction. This is a first order reaction. Okay. This is a first order reaction. So for a first order reaction, what exactly will be the rate of the reaction? P initial, as in the pressure initially, how much was it? By P final. Okay, this is exactly the rate of a reaction for a first order reaction. Now they have told us, okay, we'll just start finding out how exactly we'll get P initial, P final and all of these. Azoisopropane, okay, let's let me just erase this. First order. Okay, so here azoisopropane initially, okay, this is initially. Initially, what will be the pressure? Pressure is going to be 35, right? This is what is given at time 0. And what is the product which is being formed? Nothing. At the initial stage, there will be only reactant, there will be no product which is formed. So this is going to be 0 and 0. After certain point of time, as in at 720 second, okay, at 720 second, that is later, what exactly will be the pressure? Here there will be some amount of, like as in some amount of azoisopropane which is being converted, as in which is being decomposed to the product that we already required. So this is going to be 35 minus X. Clear? And what will be the product which is formed? It's going to be X, as in X amount of the product is formed. So from this we can find out the P total, right? P total as in what exactly is it at the time 720 seconds. So P total at 720 second is going to be nothing but correct 35 minus x plus x plus x. So this is going to cancel and this is going to cancel, which is going to leave us with 35 plus x, right? So what exactly is P total over here? Later stage at 720 seconds, it's 63, okay? 63 mm of Hg, which is going to be equal to 63. So I'm just going to find out x over here. X is going to be equal to 63 minus 35, which is going to leave us x value is 28. Clear? Now we got the x value. What is the next thing that we need to find out from here? So once we obtain the x value, we can find out what exactly is the concentration that is obtained at a later stage. Okay, so it is 35 minus 28 is going to give us the final amount. Okay, as the final pressure, what is it? PF is going to be equal to 35 minus 728, it's going to be 7, yeah, mm of Hg. This is our P final. Clear? Initially, how much was it? 35. Now, we are going to just substitute all of this in this particular equation and find out the rate. Simple as that. Rate, okay, this is the rate constant. Okay, this is rate constant. I made a mistake. And this is time. Okay, 2.303 by T. This is rate constant which we are finding out. So the rate constant is going to be equal to 2.303 by 720. The time is 720, right? Later. Into log of, what was P initial? 35. That is from the data, whatever we have. By, what is later? P final, that is 7. So if we divide this, we are going to get log 5, which is going to be equal to, let us find this out. Log 5 is log of 5 is going to be 0.699. 0.699. Clear? So now 2.303 by 720 into 0.699, which is going to give us the rate constant. So our rate constant is going to be, can I calculate this along with me? 2.303 by 720. Okay, it's going to be 0.0031 into 0.699, which is going to give us 0.002235. Okay, 0.002235. If I'm just going to move the decimal point, which will give us 2.24, right, into 10 to the power of minus 3. Okay, this is going to be our rate constant. Clear? 2.24 into 10 to the power of minus 3. Here, simple. Here we are not putting the concentration. That's the main thing. We are focusing here mainly on the pressure. Okay, if it was with respect to liquids, if it was with respect to the concentrations, then it's going to be A by A minus X, right? So that's how we used to go about the initial concentration as well as the final concentration. So here we were talking basically with respect to pressure. Clear, students? So this was a small discussion based on the NCERT questions, which can probably occur not just as the question and answers in your board, but also along with that it can actually come in the form of MCQs as well. Clear? Both the ways. It can either come as MCQ or it can come as 3-marker or 5-marker problem. So in our next session, we shall be starting off with the new chapter. So I hope this session as in this entire chapter was understood clearly. So one thing to remind your students before coming for NCERT discussion, right, before attending all the final session of particular chapter, I hope you go through all the other sessions, have a clear idea what exactly is the content that's being taught, and then you can come for the final session, as in the NCERT question and answer discussion. So in the next class, we are going to be starting with our 5th chapter, that is surface chemistry. I shall meet you all in the next class. Until then, stay tuned to Vista's Learning. So if you have enjoyed today's session, then do like, share, as well as subscribe to our channel. Thank you.